and we can use ParaView to open up the results. In fact, I've already prepared a so-called ParaView state file, sigmaxx.pv.sm you can find in the template. So let's open up ParaView and load this state file to directly see the output. So with file load state, you can load a previously defined and saved pipeline. So this is what I am doing now. You can use this pipeline on a result file in this state file, or you could also explicitly choose another result file. This is often very handy if you want to actually have the same visualization for different kinds of runs that you've done, for example, with different loading conditions. So let's ignore the error message and look at the result. Let's look at the pipeline first. We have first loaded the result file and then applied a wrap by vector filter. Actually, I want to show you the result file first. Why is the heat temperature not shown? This is because this result is saved in the first analysis step. So we have to switch to the first analysis step and look at the temperature distribution, which is as expected. We have the 20 degrees at the bottom and the 30 degrees at the top of the beam, and we have a linear temperature distribution over our cantilever. So what happens if we apply this as thermal strain? We have, of course, again switched to the analysis step 2, where we do the mechanic analysis, and then the wrap by vector result is active. We have wrapped with the mechanical displacement with a scale factor of 300, so we can see a nice deflection. As usual, as expected, we have higher temperature at the top of the cantilever, which by our thermal expansion coefficient, which is positive, leads to an expansion and a compression at the bottom. So the beam is bending downwards. We can also look at the mechanical stress. Here I'm showing the x-axis component, so the normal stress in beam direction. And you can see we have compressive stress at the top and tensile stress at the bottom, which is caused by the thermal expansion. If we also look at the range of stress values, so we rescale our analysis, we can see that we have very high stress concentrations here at the corners where we have applied the fixed support, which shows us the phenomenon that these artificially created very high stresses from the boundary conditions can have a significant impact on our analysis. So in fact, we should choose a bit more realistic boundary conditions here if this was the main target of the analysis.